Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. In this session, we are going to learn how to draw a cam profile of a roller follower which is having a motion of uniform velocity. So, this is the problem. A cam is to give the following motion to a roller follower. During outstroke, the angle of rotation, the cam rotation is 60 degree, and dwell during the outstroke is 30 degrees of cam rotation, and return stroke cam rotation is 60 degree, and dwell for the remaining is 210 degrees of a cam rotation. So here we are going to study one case, that is the axis of the follower is passing through the center of the cam or axis of the camshaft. So the follower moves here with uniform velocity during both outstroke and return strokes. So the minimum radius of the cam is 50 millimeters, and the stroke or lift of the follower is 40 millimeters. But the main thing is that in before sessions we have studied the knife edge follower, and having a knife edge follower having a motion of simple harmonic motion during outstroke and return stroke, and also knife edge follower having uniform velocity motion during outstroke and return stroke, and also the combination during outstroke the knife edge follower is moving with simple harmonic motion and return stroke with uniform velocity. Now in this session we are going to see in the place of knife edge follower we are going to use here it is roller follower. It is a peculiar follower, and it is a very special follower. The coefficient of friction is very low in this, and also one of the advantages is that it can run smoothly. And very important thing is here the roller follower, in this case it is having a uniform velocity during outstroke and return strokes. So let us begin. We have to draw the displacement diagram. The displacement diagram, how to start? First of all, before going to start, we have to take the cam rotation, take scale on x-axis. X-axis is 20 degrees equal to 1 centimeter. So during outstroke theta O equal to 60 degrees, that is in terms of linear scale it is 3 centimeters. And dwell during outstroke dwell, that is 30 degrees, that is 20 degrees equal to 1 centimeter, that is 3 centimeters. So better to increase. To get more clarity, we are going to assume as 10 degrees equal to 1 centimeter. Then it becomes 6 centimeters, and outstroke during dwell becomes 3 centimeters. Next, during return stroke, that is 60 degree, that is 6 centimeters, and dwell during return stroke, that you can tell that is 21 centimeters, that is 210 degrees. So 10 degrees, each 10 degree is 1 centimeter. So dwell during return is 210 degrees, that is 21 centimeters. So the length of the x-axis is total 21 plus 6, 27 plus 3, 30, 36. These are the 36 centimeters. You have to draw a line. And y-axis, these are the x-axis. What about y-axis? On the y-axis we consider the lift of the follower. The lift of the follower on y-axis, that is 40 millimeters. That is nothing but 4 centimeters. So draw a rectangle, okay, by comparing x-axis and y-axis. Let us begin. This is the x-axis scale, and it is a y-axis. Y-axis length is 4 centimeters, that is 40 millimeters. And x-axis is total 36 centimeters. So this is the line. What we have done that it is more length. The dwell zone is not that much required. Yeah, is not helpful to draw the cam profile. So the main important parameters for drawing the cam profile is outstroke angle and return stroke angle, and dwell between outstroke and return stroke. So here it is 60 degrees. 60 degrees. So divide this outstroke angle, that is 6 centimeters. There is a theta outstroke and a theta outstroke dwell, theta return stroke, theta dwell during return strokes. So theta outstroke, that is 60 degrees, that is 6 centimeters. Even though we mentioned here the angle, but this angle is in the form of the linear displacement, linear length. That is 6 centimeters, and it is 30 means 3 centimeters, and it is again 6 centimeters. But in drawing the cam profile, we have to show the angles. Okay. Now, after that completion of this rectangular portion, then what to do? Make a partition of outstroke, theta dwell during outstroke, theta return stroke angle, and theta dwell during return stroke. So after that, divide these parts, that is 60 degrees, that is 6 centimeters. Then again, that is S to T, that is the 3 centimeters, and T to P is a 6 centimeters. So what to do after that? 0 to 6, that is this is a 6 centimeters. Divide even number of parts. The even number of parts, it can be 2, 4, 6, or 8 and 12. Anything. But one thing is that the optimum even number of divisions are 6. Divide these 6 equal parts and draw a straight lines. Similarly, divide the return stroke angle, it is a 6. The 6 centimeters you can divide equal divisions. Suppose the outstroke is 50 degree. The 50 degree means it becomes 5 centimeter. How to divide 5 centimeters into 6 parts? You have to use the concepts of engineering drawing. Okay, let me discuss that one. If you discuss, suppose you want to divide 5 centimeters, this is a 5 centimeter. The return stroke angle comes as, suppose return stroke, that is 50 degrees, suppose that becomes 5 centimeters. It is a 5 centimeter length. So if you want to divide the 5 centimeters into 6 parts, with the scale, with the linear scale, if you use straight scale, then what will happen? You cannot maintain the accuracy. Then what to do? We have to use the concept of engineering drawing concepts to divide this 5 centimeters line into 6 parts, equal parts. How to divide, I am going to explain it. Very important it is. The most practical challenge while drawing the linear displacement diagrams. So take some acute angle, acute angle line which is having some 45 degrees. You take it. You should make it into equal divisions line. That equal divisions line is 6 centimeters. So this 6 centimeters you can divide equal parts of 6 parts. 1, 2, 3, 4, 5, like that. Okay. Equal parts you take, equal divisions. These are the 1, 2, 3, 4, 5, 6. This line is 6 centimeters which are in equally divisible. Then what to do? Keep a scale or your protractor, or not protractor, or mini drafter or a scale such a way that you have to draw a parallel lines. Join this edge to this line. Then next, same lines you join it. You keep it. It is a perpendicular lines. So with the help of set square also you can draw. Exactly, you keep it perpendicular lines you draw. Yes, these are equally divided. This 5 centimeters into 6 parts. These parts are 0, 1, 2, 3, 4, 5, 6. Then you can join. If it is 6 centimeters line, 6 parts easy to divide. Suppose outstroke is 50 degree. Okay, then how to divide equal number of parts into 6 equal number of parts? Because the return outstroke and return stroke should be in equal divisions, equal even number of parts it should be divided. By using this method, you can divide any length into equal number of parts. So next, after dividing it, okay, after dividing this equal number of parts, you join with a straight line. Then it is moving with uniform velocity. The motion comes like a linearly variation. That means it is a straight line. Join this curve. GH is the dwell and this one. So that curve, that means AGHPX. This is the AGHHPX. This is the curve traced. E is the displacement curve of a follower with uniform velocity when the rotation of the cam during outstroke is 60 degree, dwell during outstroke is 30 degrees, and return stroke angle is 60 degrees, and remaining is a dwell period. So this is the displacement diagram of any type of follower having uniform velocity. Having uniform velocity for any type of diagram. Okay, that is the line. Okay, this is the concept of drawing displacement diagram. Now we have to draw a cam profile of a roller follower. So here one more thing is that data, the roller of a radius is given as to be considered is given as 10 millimeter. That means it is radius is 5 centimeters. So 5 millimeters. So consider what is the radius of the follower? Radius of the follower equal to 5 millimeter. Okay. Now we are considering only one case, that is case A. We are considering the axis of the follower passes through the axis of the camshaft. That is the case we are going to solve. Now for a given radius, minimum radius of the cam, the minimum radius of the cam given as 5 centimeters. Minimum radius of the cam equal to 5 centimeters. So draw a circle with 5 centimeters radius by using compass. Okay, I am drawing with the help of freehand sketch. Okay, I am going to teach you only how to draw the diagram, but you have to use instruments. I am drawing with the freehand. So, but you have to use compass, scale, eraser, pencil, protractor. And if it requires, set squares also. So then only you can draw this diagram with accurately. Now, this circle is the base circle. After the base circle, the axis of the follower is passing through the center of the axis of the camshaft. Now, divide this. Now what to do? Next step. This is the first step one. Second step is that this is the contacting point of the roller follower. Take 5 millimeter height, make a center, draw a roller. The roller is 5 centimeters radius. The roller radius is 5 centimeters, 5 millimeters radius. You draw a roller. This is the contacting point. Okay. After drawing the roller, okay, with that roller, this is the center. draw a circle. That circle is known as the prime circle. Okay, I am drawing approximately. Next, divide this prime circle into the parts of outstroke angle, outstroke, dwell during outstroke, return stroke angle, dwell during return stroke. So, what is the angles here? The prime, that is a 60 degree. This is the reference line, reference axis. Make it 60 degree. Then it is 60 degree outstroke, and it is 30. That is 30. It is 12. That is 30 degree. Next, one more 60. This is the return stroke. This is outstroke angle. It is the dwell during outstroke and return stroke. Remaining angle is automatically becomes what? Dwell during return stroke. That is 210 degrees. Now divide this outstroke parts into even number of parts or equal number of parts which we divided that in displacement diagram. This outstroke angle is 60 degrees into 6 parts. Here this 60 degrees should be divided into 6 parts of the prime circle. Okay, this is 0 point 1, 2, 3, 4, 5, 6. Draw a radial lines. Okay. Next, similarly, you divide the return stroke angle, angular displacement into 6 number of parts, 6 angular divisions. Why we are doing 6 here? Because the return stroke also divided into 6 parts in displacement diagram. Now you join it. Now divide. So this is 60 degree. Equal number of parts is 10 degrees each part. So it is 6, 5. So he used it here. I am using it in different notation you can follow. So I am following whatever displacement diagram we followed here. That is 0 dash, okay. What is the base circle? We have to draw the base circle diagram. Okay. This is 0 dash, 1 dash, 4, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Okay. Up to here it is 6 dash. So join these lines, radial lines again. And it is 6 dash. Now, after what to do? We have to mark from those points, draw a displacement lines. Then next step is that take the lengths of 1 to B. This is the distance 1 to B. From the prime circle distance 1 to B, mark it. This is the B point. Similarly, take a distance 2 to C, and it is 2 to C. Then 3 to D, 3 to D. It is 4 to E. Where is 4? It is 4 and it is E. And 5 to F. It is 5 and it is F. Similarly, 6 to G is the 0.6 up to G. Okay, next 0 dash to H. Take this distance on outstroke. This is 0 dash to H. Next 1 dash to J. This is a 1 dash to point. Approximately it is J. 2 dash to K. It is 2 dash to K. 3 dash to L. It is 3 dash to L. Mark it. These are all marking points with the help of compass. Okay. From which circle? From the primary circle intersection. Next 4 to M dash. 4 dash. This is the 4 dash to M dash. 4 to M. 5 dash to N. This is the 5 dash to N. Is the 6 dash. It is the 6 dash. Then these are the centers. We have to draw the cam profile. Again, we have to draw where? The next step is we have to draw the rollers. So, take the 5 millimeter radius, draw a roller here. Take 5 millimeter radius, this is the center. Draw roller. All our roller is a 5 millimeter radius. The diameter is 10 millimeters. Okay. Next, what to do? After that, you have to join the surfaces of the roller surfaces below. Then that is the cam profile. Now, I am joining with the surfaces of the rollers. Okay, of the rollers. Okay, this is the cam profile. So, next, slowly it comes here and touches the base circle. Okay, this is the shape of a cam profile during outstroke and return stroke when the roller follower is having. Okay, when the roller follower is having the uniform velocity during outstroke and return stroke. Okay. So let me explain what is the step 1 in this cam profile drawing. Draw a base circle. This is the base circle. Minimum radius of the cam, that is 5 centimeters, that is 50 millimeters. Draw a radius with that radius. Second step is locate the point of contact of the lower roller and the center. Also mark it. Draw an axis line. This axis is passing, the roller axis is passing through the center of the camshaft. So draw a camshaft line. Then after that, mark a center of the roller and draw a roller circle. The roller is the radius of the roller is 5 millimeter. Then from the center of the roller and base circle center, draw a prime circle. This circle is the prime circle. The prime circle radius is, this is a 50 plus 5, 55 millimeters. After drawing the base circle, divide the base circle into outstroke part, return dwell parts and return stroke angles of cam rotation. After dividing, here outstroke part is 60 degrees, dwell during outstroke is 30 degrees and return stroke is 60 degrees. So after dividing 60 degrees, 30 degree and 60 degree and remaining is the dwell 210 degrees. Again, we have to subdivide each outstroke angle with 6 parts. Why it is 6? In the displacement we followed, even number of parts is 6. So outstroke is divided into 6 equal parts. So you divide this outstroke angle of cam rotation, that is 60 degree, into 6 equal parts. That is angular displacement, that is each is 10 degrees. You divide this. Similarly, return stroke also divide into even number of parts, that is 6 parts. After that, join your radial lines passing through the prime circle divisions from the center of the base circle. Then these are the radial lines. These lines are there. These are all our radial lines. After drawing these radial lines, you mark the vertical distance of the follower or vertical displacement of the follower. Take a displacement from displacement diagram. From each point 1 to B, mark it 1 and 2. 1 to B, you mark it, this is the point B. Similarly, 2 to C, 3 to D, 4 to E, 5 to F, 6 to G. Those vertical distances moved by the follower, we have to mark in the radial lines from prime circle to on the radial line. Those markings are the centers of the roller. So those centers, on those centers you have to draw the rollers, which is having a radius of 5 millimeters. So draw a circles, there's a roller. After drawing the rollers, that is the circles, the contact surface of the cam is the surfaces of the rollers. So draw a smooth curve by touching the surfaces of all rollers. Okay, that curve indicates the profile of a cam. The profile of a cam. Okay. So this is the cam profile. So here, why we have drawn touching? Why not touching the centers of the roller? You may get. Because in the case of knife edge follower, our each and everything is in contact. Here you can see. In the case of knife edge follower, what you have done? It is touching the contact points. The curve is, we have drawn the smooth curve by drawing the contact points of the knife edge follower. But here is the contact point. What is the contact point? In the case of the roller follower, it is the surface of the roller. That means the center of the roller is not, we are not passing through the center of the roller. With the contact surface is the surface of the roller. That's why we have drawn the freehand sketch by touching the surface of the rollers, all rollers. Then that is the cam profile. Now finally, the cam profile alone looks like this. If you erase all the radial lines, so it is the cam profile having a roller follower. Okay. Now, if the cam profile, when it is in touching, no, these are the rollers. The roller is touching. We may have drawn all the rollers like that. The roller doesn't move on the surface of the cam. The roller moves, doesn't go along with the cam like that, the way you mentioned here. We have shown in this direction completely. Have you seen? No. The roller remains fixed. It is fixed on one point. The cam rotates. When the cam is rotating, it gives, the rotation of the cam gives the linear motion, rising and falling of the follower. Okay. Up to 30 degrees, okay, up to 60 degree, it rises. The rising of the roller follower is, the lift of the follower is 40 millimeters. That is a stroke. Similarly, the following return stroke, it comes down. How much distance it comes down? Again, same 40 millimeter comes down. That is a 4 centimeters. It goes 4 centimeters, comes down 4 centimeters. So like that, during the rotation of the cam, once it goes 4 centimeters up, rises, and it comes down again 4 centimeters down for one rotation, one revolution of the cam. So here how the cam is rotating. The cam is rotating in clockwise direction. When during the clockwise rotation, during the clockwise, then what happens? It rises once, ascending, again dwelling is 30 degrees, it comes down, again it remains the same position because 210 degrees it is remains the same. So this is the cam of when the roller fall over. It is only we consider here one case study. What is that case study? The axis of the follower is passing through the center of the camshaft. Now, if you remove the rollers, how the cam profile looks. The cam profile looks like this, in this shape. Okay, I have drawn here using freehand but you have to use instruments such as geometry instruments, protractor, scale, straight scale, pencil, eraser, and compass. These are the instruments are required in order to get the accuracy. But this is the procedure to draw a cam profile of a roller follower when it is having a motion of uniform velocity during outstroke and return strokes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.